Okay, we're in section 23 homework. Again, the intent here is to get you to do the homework. Some students need to watch someone do homework first before they can attempt to do it on their own. Your engagement, though, in this, which means you spend time alone with this and you work hard on it, is going to pay off by being able to pass exams and then move forward. All right. So we're going to go through the questions. The point over here, I'm looking at the problem set. Someone says it's too long for me to try this. You want to do your best to do this in a reasonable amount of time. All right. Let me switch to the whiteboard, and I'll do that pretty quickly. And just give me a moment to do that. And we'll start working the problems. And certainly, when I say work the problems, we're in the homework. All right. So homework, and this is section 23, right? So, kind of reading through it. And certainly I understand a lot of times when people are looking at these problems, they say, do I need to use my pen and paper with this? Yeah, you need to use pen and paper with it. And so what I'm going to do is just look at the problem and kind of read through it. It says, how many critical points does f of x have on this interval between 0 and 8? Let's take a look at it. I'm seeing, and I'll point out what I mean, but I'm seeing a tangent line here that's equal to 0. I'm seeing a tangent line there, which is equal to 0. And then I'm seeing an undefined point there for a tangent line. It's undefined, it doesn't have a tangent there. So I'm going to claim over here, there's 3 of those. All right. Now look at the key, it does say 3. And then, where do they occur? Well, at the number 3, at the number 5, and at the number 7. I'm clearly seeing that. So next thing it says, what's the maximum value of f of x on 2 to 6? All right. So I'm going to, look at it, and they want me to go from 2 up to 6. All right, they want me to sit between that. So I'm looking at that, and I hope you realize, looking at that, the maximum value on that interval is right over here. All right. So what's the maximum value on that interval between 2 and 6? The maximum value occurs at 5, and it's equal to the number 5, right? So it occurs at 5, and it's equal to number 5. So I feel pretty good about that. Let's go to the next question. What's the local minimum on the interval between 1 and 6? Let me get my eraser out now, because my curve I got a lot of stuff over here. I'm going to erase all the stuff over here. And it says it's not between 1 and 6. Let me put 1 down. That's 1. And 6. And 6 is right over here about. All right. So what's your question? What is the local minimum value of f of x on that closed interval? Well, I'm seeing it. It's right over here. What is it? It occurs at 3, and it's equal to 3. And that's what it says over here. All right. So next thing it says, find a closed interval on which both the minimum and maximum values of f of x occur at critical points. Let's take a look at it. Get my eraser out again. Eraser's business over here. And I want to come up with a closed interval. I'm going to try to make it as easy as possible. And I'm going to say, looking at it, I know where the minimum and maximum occurs. And I'll put this down for you. The minimum and a maximum occurs over there. So I'm going to find a closed interval where a minimum actually is at a critical point. Well, let's see. I guess I could pick from 2 up to 6. So both a minimum and a maximum occurs in that. And that's one simple example. All right. So find a closed interval on which both a minimum and a maximum occurs of f of x. All right. Could you pick another one? Of course you could. All right. Another one you could have picked, one that includes the 0.7 in it. All right. Let's look at this over here, and I'll find an interval in which the minimum occurs at an endpoint. So we want a minimum to occur at an endpoint. By the way, that does not say local. It just says a minimum occurs at an endpoint. And so, looking at it, certainly, there's many examples you could pick. Let me get my eraser out though. So I want the minimum to occur at an endpoint. And so I'm going to look at it, and I want to pick an endpoint here. I'm going to pick an easy one. Let's pick this over here. All right, so I'm talking about this path over here. All right, so I'm going to claim that a minimum occurs at an endpoint over there. All right, now we're not talking about local minimum. We're saying a minimum. That's all I said. All right, so a good example of that would be between 0 and 1. All right, that's not bad. let's add number one. Let's go to number two now. All right. Yeah, so it's consider the graph. And they got this graph over here on the interval between 1 and 5. Well, I want to, kind of look at it. And I'm going to say that's between 1 and 5. You can blow these curves up if you like. All right. But I'm going to just put the points down for you. This point over here is 5, comma, 2 fifths. And this point over here is 1, comma, 2. All right. And there's a curve between those guys. All right. So the curve is like this over here. And again, they're providing a picture. All right. Consider the graph. Let's graph of this thing. Oh, these are open intervals. Sorry about that. I got to get my eraser out now. And I'll put that down for you. And my eraser. I can't put solid points there. I got to put open circles. It's important that when you're reading, you might have to revise what you read because you didn't read it fully. All right. They're open circles. All right. So circle one of the following choices. Does it have a local minimum? No, it does not. The answer is no. All right. So no, it doesn't have that. Does it have local maximum? No. So both local maximum minimum? No. All right. Neither. Oh, this is the only correct answer over here. All right. None of the above. It doesn't have maximum or minimum on that open interval. All right. Let's keep going. This one says find the critical points of the function. It just couldn't get any easier. And let's go through that with you. What's critical point going to be? It's going to be where the derivative is equal to 0. I got to get the derivative now. And what's over there is going to be 4x. By the way, the domain of this problem is all real numbers. So it's going to be 4x plus 7. And the derivative is equal to 0 when 4x plus 7 is equal to 0. The derivative is never undefined. That's good news. It's polynomial, by the way. Minus 7. So there's only one critical point, minus 7/4. All right, so find all critical points. Well, the critical value is going to be minus 7/4. The critical point is simply going to be minus 7/4 f of minus 7/4. No, don't feel obligated to do that. Now, granted, there's some variance in this one over here. Some people just say, just put this down for an answer. That's where it occurs, or put the point down. Certainly, I'm open to suggestions on that as well. All right, but it does say critical points. The critical point is a point. It's minus 7/4, comma, f of minus 7/4. All right, let's go to the next question. And this one says, find the critical points of the function. Well, again, it's polynomial. I look at its derivative. The domain of this thing is all real numbers. And I'm looking at the derivative. Where's the derivative equal to 0 or undefined? Let's write this down. 3x squared minus 15x minus 42. All right, I'm going to try to factor that guy. Let's see. I guess I could pull a 3 out, right? That would be x squared minus 5x minus, let's see, what would that be? 3 times what? I guess that would be 14, right? 30 and 12, 42. Yeah, let's keep factoring it. 3, x and x, 7 and 2, minus plus. Let's just check it. You do get x squared. Minus 7 plus 2 is minus 5x. And you do get minus 14. So there's two critical values. Where does f prime of x equals 0? At two places, when x equals minus 2, and the other one is when x equals 7. All right, so what are the two critical points? Well, going to be minus 2, f of minus 2, and the other one's going to be 7, f of 7. All right. All right, look at the key, and you're clearly seeing that. All right, this one over here, a little trickier. And I want to point out what I mean by trickier. The domain of this thing is going to be, let's see. Well, it's all real numbers except 0. So minus infinity up to 0, union 0 up to infinity. So let's take a look at this. So let's put its derivative down. So f prime of x is going to be minus 2x to the minus 3 plus 3x to the minus 4. I'm going to simplify that. That's going to be minus 2 over x cubed plus 3 over x4. I'm going to continue to simplify that. Comma down there with x4. And what do you get over there? 3 minus 2x. All right. Now, where's the derivative undefined? At 0. but 0 is not a critical number. And the reason for that is it's not in the domain of the problem. So I can't use 0. Where else is it equal to 0? I'm sorry, it's undefined at 0. Where else is it? It's also equal to 0 at, well, x would be what? 3/2, right? So I've only found one critical point, and it's at 3/2. So what's it going to be? X is going to be 3/2, function evaluated at 3/2. All right. Let's put this one down over here. Again, I can write the domain down. And domain is, I'm going to write down as all real numbers, but z cannot be, let's see, it can't be 0, and the z cannot be 8. Let's put its derivative down. As I do that, I like to rewrite the function. And again, your mileage may vary. You may say, I don't want to do that. You don't have to. You got to get the derivative though. That's going to be -1 z minus 8 to the minus 2. This would be plus z to the minus 2. I'm going to keep simplifying that. That's going to be -1 over z minus 8 squared plus 1 over z squared. Again, I'm going to combine those two terms together. That would be z squared, z minus 8 squared. And then you would get what? You would get minus z squared plus z minus 8 squared. I'm going to continue to simplify that. And someone says, why do you spend so much time doing that? You need to practice that. That's why we're trying to tell you, you need to practice that. And what would that give you? Well, z squares would disappear. And what would you get? You get 64 minus 16z. And where's this derivative undefined? And again, this is derivative, f prime is z. It's undefined at 0 and at 8, but I can't include those as critical numbers because they're not in the domain of the problem. And where's it equal to 0? When z is equal to 4. So what's the critical point going to be? 4 f of 4. There's only one critical point. Let's go back to the key and make sure that's listed for you. And it is. So it's a fairly straightforward problem, by the way. All right. So far, problems have been going quite smoothly. All right. So let's take a look at the next one. And, I'm looking at this one over here, and I'm going to put the domain down for you. And what's the domain of this guy going to be over here? So let's put this down. The domain of this thing is going to be from, let's see, -1 off to infinity. All right. And let's put the derivative down now. So f prime of t is going to be 1 minus, it's going to be a little better to derivatives, by the way. That's going to be 5. And then I would have the root of t plus 1 in the bottom. I'm going to simplify this. And let's put this down. T plus 1 root t plus 1 minus 5. All right, that's a derivative. Now, certainly what I'm looking at where this thing is undefined, and it's undefined when t is equal to -1, because I have to do by 0. Is -1 in domain of the problem? Yes, so that's a critical number. All right, what's a critical point over here? It's going to be -1 f of -1. That's a critical point. All right. So is there another one? Well, yeah, I'm kind of looking at it, and by inspection, I'm going to say it looks pretty easy to do. So when does the top become 0? And that would be when t is equal to 24. All right. Now, why is that? 24 plus 1 is 25, and the root of 25 is 5, and 5 minus 5 is 0. So write this down. So I'm going to say t is 24. Right. What's the point going to be? 24 f of 24. All right. Now in WebAssign, if they're asking you to evaluate that, let me write down what f of 24 is. It should be easy to do, by the way. It's going to be 24 minus 10, and 24 plus 1 is 25. So if you were to evaluate that, which I'm not suggesting you have to, maybe WebAssign is going to force you to do that. So minus 50. When you go up there, you get minus 26. All right. By the way, I'm not asking you to do that. Writing down the things, f of is fine by me. All right. I got to be honest with this one over here. I don't think I want to do the derivative describing, and I'll tell you the number one reason why. I'd have to get into pieces. So what I'm really going to do is I'm going to talk about, what this thing would look like to me. You know what, maybe I'll put it down in pieces for you. So let's write this down. So f of x is equal to 12x plus the absolute value of 3x plus 1. Well, this is going to be written in pieces now. What's going to be 12x plus 3x plus 1 if 3x plus 1 is greater than or equal to 0. And it would also equal 12x minus 3x plus 1 if 3x plus 1 is a negative number. I got to keep simplifying that. And what would you get over here? 12x plus 3x is 15x plus 1. And I got to simplify that. What's going to be x greater than or equal to minus 1/3. That's done. Let's do the next one. 12x minus 3x is going to be 9x minus 1 if x is less than minus 1/3. Now, by the way, I'm not saying you have to go through that, but I hope you realize that these are lines, right? They're definitely lines, by the way. And what do we notice about the lines? They change at the number minus 1/3. So to the right of minus 1/3, the slope of the tangent line is going to be 15. And to the left of minus 1/3, the slope of the tangent line is going to be going to be 9. All right. What happens over here? It's going to be a sharp corner. The slopes are going to change. So you can have a slope of 9 here, and then over there, it's going to be a slope of 15. So we got a sharp corner at this thing over here, right? We didn't take a derivative. We got a sharp corner over there. So what do I know? I now know that this thing's got a critical point at, I'll write this down for you. So the critical point is going to occur at minus 1/3, f of minus 1/3. Again, if you want to evaluate the minus 1/3, you can. I'll just write that down for it. It's pretty easy to do. Minus 1/3. You would get, let's see, minus 4. And then you would get, let's see, minus 1/3 times 3 is 1. Minus 1 plus 1 plus 1. Yeah, minus 4. All right. This is a safe bet, by the way. All right, not bad. Okay, let's do the next one. And it says find all critical points of this function over here. And I'm always saying you got to understand what they're asking for, the critical points. And this could get really tough, by the way, because it's a trig function. And if you don't remember your math 120, it's going to be impossible for you to do. Well, let's write this down. So you get g theta. I got that written over there. I'm going to write down g prime. And that's going to be 2 times the sine of 27 theta times, well, now I got to do the inside derivative. Sine is going to be cosine, right? The cosine of 27 theta times the derivative of the inside, which is going to be 27. I'm going to simplify this and say it's 27 times. Now this guy over here, I'm starting to realize it looks complicated, but I kind of recognize it. It's really a double angle formula. And it's going to be the sine of twice 27 theta, which would be 54 theta. All right. So the question goes, is that derivative ever undefined? And the answer is no, it's defined everywhere. But is it ever equal to 0? And what I know about the sine function, I want to put this down for you. The sine function becomes 0 at an infinite number of locations. All right. Now, what's it going to be? I'm going to say a nice place to start would be at 0. I'm going to put in degrees first, by the way. 0 degrees plus, there's a repeating pattern over here, and it's 180 degrees. Okay. It keeps repeating itself. All right. Now, I'm going to say, I don't think you want to write that down, but I'm going to write down, that means 54 theta would equal that. All right. This is the argument, by the way. So I'm going to go back to the radian measure. And the reason why, because I didn't have to answer the question, by the way. So it's 54 theta. Well, 0 degrees is 0 radian. I'm not going to put that down. But 180 would be pi. This, you understand that k is any integer at all in the universe. All right. So what's theta? It's going to be, let's take a look at that. I got to divide by 54, right? So it's going to be pi over 54 k. Again, the understanding k is some kind of integer. So what's our question again? Find the critical points. There's an infinite number of those. What are they going to be? Well, they're going to be in the form of this over here. So pi over 54 times k, g of pi over 54 times k, with the understanding k can be any integer. All right, look at the k, and I see that written over here. And again, they say k is an arbitrary integer. Again, you may have to go back and review your Math 120 material because pre-calculus, which includes trigonometry, is a prerequisite for doing well in calculus. Let's go to the next question, which could be number 10. And let's take a look at this one over here. And I'm going to write down the domain first. And the domain of this problem over here is going to be, well, x greater than 0. This is the domain of it. All right, let's get our derivative. And, I want to be careful about it. And that's going to be, let's see, the derivative of x is going to be 1 times the natural log of 4x plus x times the derivative of the natural log of 4x, which is going to be 1 over 4x times 4. I still want to simplify this. And I'm going to write it down as, let's see, well, I think this is pretty simple, right? What are you going to get? 1 plus the natural log of 4x. And this is a derivative. All right. So then the question becomes is, what do they want you to do? I got to go back and read the question, find the critical points. Well, I have to be honest with you. This is going to be, it's still, I'm looking at this, x is still greater than 0. I know that much. I'm wondering, does this thing ever undefined on the interval x greater than 0? No. Is it ever equal 0? I don't know. Let's write this down. 0 equals 1 plus the natural log of 4x. Well, this really is, going back to Math 119, can you solve a log equation? What's going to be minus 1 equals the natural log of 4x. And I'll write this as e to the minus 1 equals 4x. And then I would divide both sides by 4. And what do you get? E to the minus 1 over 4 would equal x. Now, by the way, I hope you realize that e to the minus 1 over 4 is a number greater than 0. So it's definitely in the domain of the problem. So I got my point. And what's my point going to be? Well, it's e to the minus 1 over 4, and then it's going to be f of e to the minus 1 over 4. There's another way to write that down. That's 1 over 4e, and this is f 1 over 4e. Any way you write down is fine by me, by the way. They're written over here for you. All right, so the next one, this is number 11, and the domain of this problem over here is, looking at it, is all real numbers. And I got to get its derivative now. Let's put this on the side. So f prime, and that's going to be 9 e to the 4x plus 9x e to the 4x times 4. I need to simplify this. And I'm going to say 9 comes out and e to the 4x comes out. This was known as factoring the problem. This would be 1 plus 4x. This is defined everywhere. And the domain is everywhere too. And the question is it ever equal to 0? Yeah, at one place where x equals minus 1/4. So I find one critical point, which is minus 1/4, f of minus 1/4. Again, I would recommend looking at the answer key and making sure you're getting that. All right. Okay. This one, again, you may not remember this, but I got something over here. I just want to go back and review with you that this is the arc cosine function. And the arc cosine function is defined on the, they got it. It's really defined on an open interval, but they're giving me a closed interval. I'm sorry, it's defined on a closed interval. They'll give me an open interval. That's good. That's fair enough. They gave it to me. So what I'm going to do over here, I got the domain of it. This is the domain over here. They gave it to me. All right. So let's write this down. So what are you going to put? F prime of x. Well, do I remember the derivative of arc cosine? I think so. It's minus 1 over the root of 1 minus x squared. And the derivative of 8x is just 8. I got to simplify that, right? So what do I get over here? I got to put this down for you. So f prime of x is going to be common denominator. And that would be 8 root 1 minus x squared minus 1. All right. So, I'm looking at it and I know there's trouble over here, but, someone said, oh, the trouble's at plus or minus 1. Not really, because it's not in the domain of the problem. So I just have to really worry about one thing and only one thing. And that's when the top becomes 0. And let's write this down for you. Think I can do that? Square both sides. And again, I'll think about it later. I take 1 from both sides. That would be minus 63 then, right? That means x squared is 63 over 64, which means x is equal to plus or minus the root of 63, and the root of 64 is 8. The question is that on the interval? I hope you realize that's a proper fraction, and a proper fraction is certainly on that interval. So I get 2 critical points. And what are they going to be? Let's write them down for you. Minus root 63 over 8, f of minus root 63 over 8. And the other one's going to be root 63 over 8, f of root 63 over 8. And these are my answers. And those answers are listed for you. All right, not a bad problem. All right, let's go to number 13. And find all critical values. And again, what I'm looking at over here is they give me a domain. They give me 0 to 3. So this is the domain of the problem. And let's write this down. F prime of x. Well, it's going to be easy. 18 x squared minus 54 x plus 36. Well, I'm looking to factor this guy. I'm going to say 18 comes out, and you get x squared minus 3x plus 2. I'm still looking to factor. And what do you get? X and x, 2 and 1. And what would you get over there? I guess you get minus minus, right? Let's just check it. You get x squared. Let's see, minus 2 minus 1 is minus 3. Yeah, things look pretty good. So when does this thing become 0? When x equals 1. That's certainly on the interval. And when x equals 2. And that's certainly on the interval. So I found 2 critical points. All right, what are the critical points going to be? Well, the critical point is going to be 1, f of 1. And the other one's going to be 2, f of 2. All right. So I got my 2 critical points. Let me see if they ask for it. Find the critical points in the extreme. Oh, the extreme values. All right. So I got to do the extreme values of the problem over here. And someone says, the extreme values. And let's take a look at it. All right. So what I really want to be careful about it too. So I got to write these down over here. And I'm gonna write down everything. I'm gonna write down, beginning to end of the problem. So let me write down f of 0 for you. And what's f of 0? It's 0. And I'm going to do the endpoint f of 3. And what's f of 3? Well, it's a little bit more challenging for me. So it's going to be 6 times 27 minus 27 times 9 plus 36 times 3. All right. Now I'm going to emphasize, the way I do arithmetic, the way you do arithmetic may be different. But the bottom line is we should agree upon the arithmetic. I'm going to look at the first 2 terms and factor 27 out. And what would I get? 6 minus 9. And then when you get 36 times 3, I think I can do that, by the way. 36 times 3 is 90 and 18, which is 108. And this can be 27 times minus 3 plus 108. And you have to say, I can't do arithmetic. You got to learn. It's really that important. Minus 81, and I'm not beyond making a mistake. I'm not saying that. That's going to give you minus 19 and minus 8. I'm sorry, I made a mistake there. That's crazy. It's going to give you 19 and 8, which is 27. All right. Let's write down f of 1 though. Should be easier. That's going to be 6 minus 27 plus 36. And let's see, what's it going to be? Let's see, minus 20, 27, 36 is going to be 3, 9, 15, right? And let's do f of 2 now. All right. So what's f of 2? Oh boy, what's f of 2? I got to do arithmetic again, right? So 6 times 8 That's not so bad. Minus 27 times 4 plus 36 times 2. I got to do that. I don't want to do it. You have to do it. 48 minus, let's see, 80. That's going to be 108, right? Let me just check that again. 80 and 28, 108 plus 72. Oh boy, I always hate doing arithmetic, but anyway, let's do it. 72 and 48, that's 120 minus 108, 12, right? Okay. So, someone says, oh, that's so much work. I don't think I could ever get there. So if you were to plot this out, not that I want to plot it out, but I hope you realize you got a couple different things over here, and I'll circle them for you. So at 0, you got, 0. At 1, you got 15. All right, you got that. At 2, you got 12. And at 3, you got 27. 27's over here somewhere. And certainly if you were to trace that in there, something like this over here. Okay. So what I want to get over here is certainly they didn't ask you to graph it. I just want to go back over here. I want to make sure they didn't ask me to graph it. Find the critical points. Did I find the critical points? I think so. The critical points are going to be, I think I wrote them down. Yeah, they're right over here. Did I find the absolute maximum occurs? I don't know. Maybe I didn't. Well, over here, I'm going to put over here. This is the absolute maximum. This is a relative minimum. This is a relative or local, a maximum. And this over here is an absolute minimum. All right, let's go back over here and let's see if we got it right. So it says the absolute maximum occurs at F. Yep, I got that right. And the absolute minimum occurs. Yep, I got that one right too. All right. All right, let's look at number 14. What I like about this problem over here, they give me endpoints. All right, so they give me the demanded problem. What I have to do is, this is a nice function. It's continuous on that entire interval. It's continuous everywhere, by the way, but certainly in that interval between 0 and pi over 2. I got to get the derivative for 14. So what's f prime? Let's write this down. And that's going to be 4 cosine minus 4 sine. And certainly defined on the interval. What I need to do is I need to find out where it's 0. Let's write this down. So where's it equal to 0? When 4 cosine x is equal to 4 sine x. All right. I'm going to try to solve that. It might be difficult, but I think I can do it. And I'm going to divide both sides by 4, and then cosine x equals sine x. Now, I hope you realize the sine and cosine are never simultaneously 0, so it's okay to divide both sides by something. I'm going to divide both sides by cosine. And what do you get? You would get tan x is equal to 1. And I got to go over here and say, when is the tangent equal to 1? When x is equal to pi over 4 plus, well, what's the repeating pattern for the tangent? The tangent repeats itself every, well, I thought pi over 2 to pi over minus pi over 2, every pi, right? So pi k. All right, so I'm going to start writing them down for you. And again, the only ones I need to write down is between 0 and pi over 2. So if you wrote these down, what do you get? You get pi over 4. Well, if I go to the next one, I'm beyond pi over 2. So there's only one critical point, and it's pi over 4. All right. So what I want to do now is, I know the critical point, pi over 4, f pi over 4. That's pretty simple. But then they want me to do the extremes on it. And I got to write it down. I mean, I got to do f of 0. Well, that's pretty easy. What is going to give you? It's going to give you 4. And I got to do f of pi over 4. And really, thank God for easy numbers. And that's going to be 4 times 1 over root 2 plus 4 times 1 over root 2. Yeah, you need to know math 120, certainly. And what's that going to give you? 8 over root 2. I'm going to simplify that by multiplying top and bottom by root 2. And what would you get over there? On bottom, you get 2, so it's 4 root 2s. All right. And I got to do f of pi over 2. That's the endpoint, right? And let's take a look. And again, yep, pi over 2. So it's going to be, that's going to be 4. All right. So, I mean, if you drew the picture of this thing over here, starting at 0 and going to pi over 2, well, you get some points over here. And at 0, it's equal to 4. And then at pi over 4, that number is bigger than 4. It's 4 times the root of 2. And then this one over here. So I'm going to say over here, these things are mins. This is a min. And this is a max. All right. This is global. And this is global. And this is global. I'm spelling global wrong. Sorry about that. It's at the endpoint. They're not local, by the way. So let's take a look at the K. See how we did. We got the critical point. It says the absolute max occurs at pi over 4. Did I do that right? Yep. I put the global max down. Absolute minimums occur at 0 and at pi over 2. We got those right too. All right. This one says plot this thing in appropriate viewing rectangle. Determine the maximum values in the graph and the exact values in calculus. So, granted, plotting it might be difficult, but let me just go through, my rough sketch of this 15. So f of x equals 5 root x minus x. And the domain of this problem over here, it starts at 0, goes off to infinity. And certainly, my rough picture of this thing over here, if I start at 0, it gets 0, right? And then, kind of plotting points over here. Let's take a look at that, plotting points over here. So, and I guess it's really kind of hard to do that, but I think I can handle it. I'm going to pick some values over here and let's take a look. And I'm going to say I'm going to write down, I'm going to solve for 0. So 5 root x equals x. Well, this would be 25x equals x squared. I'm just going to get a rough picture of it, right? And so, well, I got to do that. I know 0 certainly works. I got that point. So that means 25 is equal to x. That would work too, right? So I can put 25 over here. And what do I know between those two? And this is just my pre-calculator, not the best thing in the world, by the way. But if I were doing that, I'm going to say it's got to be positive between these two. And then what happens? It goes negative big time. All right. Now, I'd be honest with you, without using a really good calculator, I don't think I could get this thing over here. Right? I don't think I could do it, which would be my global and local maximum. But anyway, what I'm going to do, let's read the thing again. It says, determine the maximum value. Well, I know it's over here somewhere. I just don't know what it is. All right. I know it's between 0 and 25. So I'm going to go to my calculus. All right. And let's write this down now. Let's do the calculus now. So I got to write this over here, f of x. And what do you get over there? Well, I'm getting a little better with derivatives. You get 5 over 2 root x minus 1, common denominator. This would be 5 minus 2 root x. I'm sorry, this is f prime. Sorry about that. And I think I know when that equals 0 too, right? So it's undefined at 0. Not sure. That's a critical number, by the way. That makes sense over here. I see that. And where's the other place? Well, let's write this down. 5 minus 2 root x equals 0. 5 equals 2 root x. Square both sides. 25 equals 4x. Divide both sides by 4, you get 25 quarters. So I now know where this is. And what's that point over here? It's 25 quarters f of 25 quarters. All right. Now, by the way, I guess I could do that arithmetic for you. I don't know if it's important for me, but I guess I could do that. But what I want to do is I want to read it. It says plotted. I did my rough graph of it. I know the point now because I used my calculus. But let's take a look at it plotted. I did the plot. Not a great plot, but appropriate viewing rectangle. I did my appropriate viewing rectangle. I got the graph, got the derivative. And let me see if I got the right answer. Let me go to the next page. I don't know. And yeah, right over here. By the way, I like their picture better. I'm seeing this over here, and that's the maximum point over here. What's the maximum point over here? 25 quarters, f of 25 quarters. All right. So since critical numbers are at x equals 0, I do see that. 25 quarters, global max occurs 25 quarters, as we stated. Let's go to number 16. Number 16 is, find the maximum min values of the function on that closed interval. Let's write this down. I got to get its derivative. So y prime, that's 3 times 14, 30, and 12, 42, plus 28, minus 14. Well, I'm going to factor 14 out. That would be 3x plus, 3x squared, 2x minus 1. Let's hope it's factorable. We've got nasty numbers. 3x and x, 1 and 1. Looks like plus minus. I'm still going to check it. You get 3x squared. Plus 3x minus x is 2x. Yep, works out beautifully. So what do I get? X equals, let's see, 1/3, right? And the other one would be x equals minus 1. Are those critical numbers on that interval? Of course they are. 1/3 and minus 1 are both there. So I got a bunch of stuff to do now. And it's kind of tedious, and I realize that. I got to do f of minus 2. I have to do f of 2. And I've got to do those two critical numbers, which is 1/3 and minus 1. So I got to do f of minus 1. And I have to do f of 1/3. So I like to do easy things first. And the easiest one for me to do, believe it or not, is minus 1. What do you get? Minus 14 plus 14. Let me look at the function again. Plus 14, which is 14. That wasn't bad. I got to do 2 now, and it's tough for me. I'll be honest with you, but I'm gonna try to simplify it. So it's gonna be 14 times 2 cubed, which is 8, 2 squared, which is 4, minus 2. And I think I can do that. So it's going to be me what? That's going to give me 10, 140. I'm going to do minus 2 now, which is going to be 14. Again, I'm trying to do it easy, right? It's going to be minus 8 plus 4. And then plus 2. What would that give me? Let me see. I'd get 6 times 4, 16 and 24. Let me make sure I'm doing that right. Minus 2, minus 8 and a 4, and minus plus 2. I'm sorry, I made a mistake there. Let me check it out again. 6 minus 8 is minus 2, minus 28. All right. Let me keep going. I got to do the 1/3. It's a killer, but I got to do it. It's going to be 14. What's going to be 1 over 27 plus 1 over 9 minus 1/3. Now that's really a nasty, right? I'll keep going. Push it aside. And it's going to be 14, common denominator 27, right? So 1 plus 3 minus 9. Got to keep doing it. And let's see, 1 plus 3 is 4. 4 minus 9 is minus 5. Minus 50 minus 70 over 27. I think I can divide by 7, right? Minus 10. I'm sorry, I can't do that. Let me see if I did that right, by the way. 1 plus 3 is 4. 4 minus 5, minus 50. Yeah, I think I did okay. So I got this over here. Let's take a look at this thing over here. So what's the biggest number? This is the global max. What's the smallest number? This is the global min. What are those other two guys? Well, they're going to be locals, all right? What do they want me to come up with? Let me find the maximum value of the functions. I've done that. So what's the global minimum? I got that right. What's global maximum? I got that right over there. Let me see if we did the computations right though. 14, and yeah. We did it right. All right, let me go to the next page. Let me see if there's another problem here. 17. Yeah, a lot of problems in this set, isn't there? So let's take a look at this one over here. I'm getting a little better at it. I know I got to take a derivative over here. So let's write this down for you. So f prime of x, that's going to be x minus 4 squared, x minus 4 times 2x minus x squared minus 7, derivative of the bottom is 1. I got to simplify that. That's x minus 4 squared. Then you get 2x squared minus x squared, which is x squared. Let's see, you get minus 8x. I'll write that down. Let me see if I'm doing that right. Minus 8x. And then plus 7. I got to factor that guy. We'll check it with the key too. I make mistakes all the time. And what do you get over there? Let's take a look here. Get x and x. 7 and 1 minus minus. Yeah, it looks pretty good. This is f prime. What are the critical numbers? 4. But 4 is not in the domain, is it? Can't use that. What's the other number? 1, but that's not in the domain. Can't write that down. So the only critical number is 7. That's the only critical number. So what do I got to do? I got to evaluate this thing at f of 5, f of 7, and f of 8. All right. So what's 5 going to give me? Well, it's 25 minus 7, which is 18 over 1. So 18. That was easy. Let me do 7. 7 squared, all right, it's on the side, 49. 49 minus 7 is 42. And 7 minus 4 is 3. And 3 goes into 42 14 times. Let's do 8. More difficult for me. It's 64 minus 7. And 8 minus 4 is 4. 64 minus 7 is going to be 57. All right, I'm going to erase my baby arithmetic. All right, I'm looking at it. And I realize this is really tough to look at. So let's see. 4 goes into 57. Let's see. Let's write this down for you. Let's see. 14. That's 16. And the remainder is 1, right? Okay, what's the maximum? This is clearly the maximum. What's the minimum? Boy, I'm glad I did that arithmetic. This is the minimum. All right, as stated. Let's go to number 18 now. And again, the trig stuff really, I know it causes those students for a loop. The reason for it, they may not have mastered the 120. And so you're trying to build on a foundation that's not solid, and things start to collapse pretty quickly. But I'm going to write this maybe a little differently. And the reason for that is because I don't want to take a derivative of a product. So I'm going to use a double angle formula. So f of x equals 3 times 2 sine x cosine x plus 3. So f of x is equal 3 times, this is the sine of 2x. Now, someone says, I wouldn't have done that. Well, then don't do that. You do what you want to do. I'm going to write down the derivative now. And that's going to be 3 cosine 2x times 2. Well, that was easy. F prime of x is going to be what? 6 cosine of 2x. Well, that's easy. Now I'm going to just solve for 0. It's defined everywhere. So 2x, when does the cosine equal 0? At pi over 2 plus, and I got one of what I'm doing over here. It goes like this over here, pi over 2, and it repeats itself every, let's take a look at that. So this is pi over 2. This is 3 pi over 2, right? And what would that give you? Well, 3 pi over 2. What's the difference between those? It would be 2 pi over 2 pi, right? Pi k. Let me write this over here. X equals pi over 4 plus pi over 2 k. Again, you understand that k is some integer value. So what do you got over here? Well, I got this interval over here, and I've only got one number in the interval that satisfies it. So what's that number that satisfies this? There's only one critical value, and that's x equals pi over 4. So there's things you have to evaluate. F of 0, f of pi over 4, f of pi over 2 at the endpoints and the one critical point on the interval. Where do you do that? Well, you do it in the function itself over here. All right. So let me do f of 0 first. And what's f of 0 going to be? Well, it's going to be 3. That was simple. And I want to do f of pi over 2. That's the endpoint, by the way. What's that going to be? Also equal to 3. The only thing that really caused me struggle is that, f of pi over 4, but I'll write that down for you. And what do you get? 6 times 1 over root 2, 1 over root 2 plus 3. What does that give you? 6/4. I'll write this on the side for you. Plus 3, which is going to be 3 halves plus 6 halves, which is 9 halves. Did I do that right? Let me just see if I did that right. 1 over root 2, 1 over root 2. Oh, I'm sorry, I made a mistake. It's 6 halves. So 3 plus 3 is 6. All right, good, I checked. All right, what's the maximum? 6. What's the minimum? 3. We got those covered. All right. Number 19. Thank God for pictures. And I mean that. All right. So what I'm pointing about pictures over here, we hope you're looking at the pictures, and we hope you're willing to look at the pictures and to read. All right, so find the maximum and minimum values of function. Well, I want to be honest with you. Looking at this over here, this looks clearly like the maximum in the problem. I got to be honest with you. Over here, I'm going to say, you got some candidates for minimums. All right. What's your trouble over here is a derivative. So what I'm going to claim over here is that I think the derivative, I want to point out, is easy to find. What may not be easy for you to do is to analyze that derivative. So what I'm going to claim over here is, kind of factoring it and then looking around for solutions to the problem. Here's the problem. A lot of students have a tough time with pre-calculus. There's no doubt about it. I would definitely consider this thing to be a tough problem for a lot of students, pre-calculus level, but it can be done. So what I'm going to claim over here is please read. Also, look at the provided graph. And you should be able to understand that once that's done. All right, I'm going to call it quits. And if you need help with this, please come during office hours. I'll be more than happy to help you.